Hi everyone, welcome back. So let's do one more example. Example 3.7. Now what do we have here? Well, we have a bunch of forces, distributed force 2, and they're all acting on this beam. And we want to find the magnitude and location of the resultant R such that it'll have the same effect on this beam. Get rid of all the forces, replace it with R, same effect. Now we're going to neglect the way of the beam, and we're not going to worry about these reaction forces, but we'll go from there. So what I want you to do is I want you to pause right here. I want you to try to do this on your own and see if you can. I'll give you a hint. Remember that in the end, the sum of the moments is going to be equal to R times that distance. So if you can figure out what the sum of the moments are, if you can figure out what the resultant force is, you should be able to solve for its position. When I take the sum of the moments, I would take it around point A over here. So pause, try it, see if you can do it. If you can't, come on back and I'll help you out. Now, for these kinds of problems, there's a few different things we need to do. First off, we're going to have to figure out what the resultant of that distributed force W is going to be. Remember, for a distributed force, it's always the area of the distributed force, so 2 times 14, which will be 28 kilonewtons, and that applies through the centroid, which for a rectangle is right in the middle. Now we're going to calculate the total resultant force, which means we add in together all of these forces. So that'll be 28 kilonewtons plus 8 kilonewtons plus 3 kilonewtons, so it'll be negative 39 kilonewtons. It's negative because it's pointing down. Normally I would say that up is positive. And then we have to calculate the total moment, which is force times distance. Force times distance, I do it from a particular point. So I'm going to do it from point A. So this is a vertical force. I need the horizontal distance. So that would be 5 meters to the 3 kilonewton force, 12 meters to the 8 kilonewton force. And then this one, well, that would be, let's see, 16 plus 7 would make that 23 meters to the 28 kilonewton force. I calculate that and I get negative 755 kilonewton meters. That's just force times distance, and then force times that big old distance. And now we can calculate the position of the resultant force, because this resultant force has to have the same magnitude of force and the same magnitude of a moment. And our moment is equal to force times distance. We know what the force is, we know what the moment is. That's an equation with only one unknown. So we plug it in here. What do we get? We get 19.4 meters. Be very careful with your signs, otherwise you're going to get it over here by accident. And so if it's not on the beam, you know you've made a mistake. Okay, so that's it. That's how you do these problems. It's just a few steps, but you have to master them. And I would say that probably the biggest issue for a lot of people is going to be the moments. A lot of people struggle with moments. It's a force times a perpendicular distance, okay? So you draw that line straight through your force going up and down, and you say, okay, from this point, I'm going to draw a line straight over to it that's perpendicular. What is this distance? What is that perpendicular distance? That can help. Do that for all of your forces if you need to. And if you have a force that's at an angle, then break it into components. Break it into components and then redo it with doing the vertical component and then the horizontal one. So, hope this helps, and I'll see you all next time as we do another example. Have a great day.